I said this would be a tutorial on the calculus of polar curves, so let's start with none other than the slope of a polar curve. So recall that x equals r cosine theta and y equals r sine theta. Well, if we let r equal some function of theta, then we're left with x equals f of theta times cosine theta, and y equals r, or f of theta times sine of theta. Now, what we have here now is a set of parametric equations in terms of theta. So where do we go from here? Well, first let's differentiate both the x and y terms. If we have x equals f of theta and times cosine of theta, we want to differentiate with respect to theta, so dx d theta equals what? So we have product rule, f of theta times the derivative of cosine theta, which is negative sine theta. So f of theta times sine theta, and there's a negative, and then we have to add cosine theta times the derivative of f of theta, which is f prime of theta. So plus cosine of theta, f prime theta. Alright, now let's go with dy dx, or dy d theta, sorry. dy d theta equals, well, we have f of theta times the derivative of sine theta, so that's f of theta cosine theta, plus sine of theta times the derivative of f of theta, which is sine of theta, f prime of theta. Now we have two different derivatives, but what do we do with them here? Well, we want dy dx because that's the slope, and we are drawing on the plane with the x and y's. So how do we somehow cancel out the d thetas? Well, if we divide dy d theta and dx d theta, what does that do? Well, this equals dy d theta times d theta over dx, and the d thetas cancel out, leaving us with dy dx. So the formula for dy dx is f of theta cosine theta plus sine of theta times f prime of theta all over cosine of theta f prime of theta minus f of theta times sine of theta. And this is your formula for finding the derivative, or not the derivative, the slope of a polar function.